Hi everybody, welcome back. In the last couple videos we were looking at summation notation and applying summation notation to calculating means and standard deviations. In this video I just want to talk about a few important functions that we use in econometrics. We're going to start with linear functions, and then we're going to go to nonlinear, and there we're going to talk about quadratic functions and log. And I may mention at the end exponential, but I won't get into the details there. But again, all of these details are in the Appendix A of the Introductory Econometrics textbook by Wooldridge. Okay, so first we're going to start with linear. And within linear, we're going to start within a single variable. Okay, here, what we're just thinking of, this should be going back to like junior high algebra. The slope of a line, right? So we have an x and a y. We're going to call this b. We're also going to be calling this in econometrics beta 0. And then this slope is commonly thought of as m. We're also going to be thinking of this slope as beta 1. So then the slope of this line, the linear function, is y is equal to b plus mx. That's how you, or at least how I think many people are taught in algebra. How we're going to be thinking about it in an econometric notation is beta 0, capital beta, plus beta 1 times x. And this is a simple linear equation, very common to do, the most basic ordinary least squares regression. The beta 0 is the intercept, and the beta 1 is the slope, or in our terms, the marginal effect. Of x on y. Sometimes also called partial effect. Okay, and so another thing about beta 1 is that we can think about the change in y is equal to beta 1 times the change in x, so that we have beta 1 is how does y change when x changes. For example, we could think about how does the grade change when the number of study hours changes. Okay, more on this beta effect, but we're going to look at it because most commonly we're not using one variable but multiple variables. Okay, and so this one we can't really visualize on a 2D plane or anything. We could look at two variables in three-dimensional space, but it just starts to become weird to think about these visually. So we're just going to use equations, and we're going to use two variables. So our intercept, beta 0, plus beta 1 x1, plus a second variable x2, beta 2 x2. So again, what we have is the change in y is then equal to beta 1 times the change in x plus beta 2 times the change in x2. Now, if x2 does not change, that is x2 change delta, I should have written that up there. Delta is just the uppercase Greek symbol. That means change in. Okay, so if there's no change in x2, then the change in y is just equal to beta 1 times the change in x1. So thus, as above, beta 1 is equal to the change in y over the change in x holding other variables constant. That is, x2 is not changing. And to write that out, we can say beta 1 is the marginal or the partial effect of x on y that is beta 1 beta 1 is the effect of x on y. We'll just end it there. Ceteris paribus, meaning all else held constant. Okay, and this too we're going to be revisiting once we start doing regressions, but this is how we're going to be interpreting these regression coefficients, these marginal effects. Okay, yeah, I'm actually just going to stop here again and make another video on nonlinear functions, looking at quadratic functions and logarithms. Okay, thanks everybody.